Hello Hopewell, this is Mr. Steinberg. Today's lesson is 9.5, using the law of sines. So far we've been able to use our trigonometric ratios to solve right triangles. To solve a triangle really means to find a missing angle and missing sides and completely know the measurements of all three sides and all three angles. Our warm-up today consists of two questions. Here, the first one, the sine function. We need to find the angle that gives us a ratio of 0.89. Traditionally, you input an angle and get out a ratio. If we have the output, we're looking for the input, which indicates we want to use a sine inverse. You input the ratio, and it's going to tell us what the answer is, and that would represent an angle. Once more, always, 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 because we want an answer in degree mode, I'm just going to double check. I mean, it wouldn't be a bad thing to have an answer in radian mode. It's just I don't know what that really indicates. I'm going to hit second and sine. That gives me my sine inverse. 0.89, plug in the ratio, hit enter. We're going to approximate the three decimal places, so 62.873. So theta is approximately equal to 62.873 degrees. For our second question, we have fractions. What I can do is multiply all the way through by 6x, cancel the 6's, cancel the x's, get a new problem, or I can cross multiply. Let's do the second thing. So I'm going to cross multiply 6. Sine of 73 degrees is equal to x times the sine of 52 degrees. To solve for x, I need to divide both sides by the sine of 52 degrees. Divide by the sine of 52 degrees. Which cancels it out, and this is going to approximately tell us what the value of x is. All I need to do is calculate this side. Just make sure that you're putting things in the calculator properly. Every time I notice when I plug in a sine, it opens this parenthesis for me, so I always want to close that. Because I am using degrees for the angle measurement, I know we're already in degree mode, I check that. Now I'm going to divide it by the sine of 52. Close that parenthesis because it's good habits. We'll round to three decimal places. The answer, I don't know what the value of x really represents or means, if we're rounding it to three decimal places, would be 7.281. So let's get into what the law of sines is and what it tells us. In this box, there's a definition of what a law of sines is and can be used for. Law of sines states, given any triangle ABC, I guess they mean any, meaning not necessarily a right triangle, with side lengths of little a, little b, and little c, the following is always true. Just a reminder, side lengths are always indicated using a lowercase letter, and angles are always using an uppercase letter where the vertex is for each of these three angles. Okay, so here goes. The sine of angle A divided by side length A is equal to the sine of angle B divided by the side length B, which will also be equal to the sine of angle C divided by side length C. In short, usually we have an equation with one equal sign. I think this formula just means that all three ratios of the sine of an angle divided by its side length that it corresponds to across across from the triangle, these ratios will always be equivalent or proportional or equal to each other. Usually we only use two statements. I might keep the first term and the last term and make them and set them equal to each other using the transitive property, or just maybe use these two. But this is how it really works. We're just going to use two out of these three. The law of sines can be used to solve a triangle when two angles and a side length are known. Angle, angle, side, and or angle, side, angle. Or when two sides are given and the opposite angle is across from one of those sides. So, long story short, I don't really memorize this. What I do instead is I just know I will use the law of sines if within a triangle I have an angle that's opposite a side length. If I have an angle across from a side length and one other piece of information, it could be another angle, it could be another side length, I can use the law of sines. So I need to have things that correspond, an angle and a side length. So here's the term to solve a triangle. Solving a triangle really means to find all the missing pieces to it. In our directions here, I just underlined it. To solve ABC, meaning we're going to find all of the missing pieces. We're going to draw a picture if there is not one given to us. But again, we're using the law of sines to completely identify all the missing measurements for a triangle. So getting started with our first one. Solve the triangle ABC with angle C is 107 degrees. They provided us a picture. I'm going to mark 107 in there. Angle B is 25 degrees, so at the vertex B, I'll put 25 degrees. Little b means side length B is across from angle B is 15 units. So this indicates I can use the law of sines because I have a side length across from a known angle. Since the only other piece of information is angle C, I think what I'm going to do first is solve for side length C using the middle and last statement. I'm going to set up this proportion. The sine of 25 degrees divided by 15 is equal to the sine of 107 degrees divided by little lowercase c. Just like in our warm-up, what we're going to do is we're going to cross multiply. So a little trick, a little bit of cheat or a hack, what you can do is the two numbers, the two terms that have values, multiply these first, then divide by the other number. That will always equal your variable. So I'm going to do 15 sine 107 degrees, and then I'm going to divide it by the sine of 25. That trick will work. Okay. So first, 15 sine 107, close the parenthesis, divided by sine of 25, close that parenthesis, hit equal. We're going to round it to 3 decimal places. We get 33,942. This represents a side length of 33.942 units. I don't know what the units are, we'll just call them units for now. This only leaves us, so right now I have 2 sides, I have 2 angles. I'm missing a third angle and the third side length. Now I can't use the Pythagorean theorem because this is not a right triangle. I can't just say like a squared plus b squared equals c squared. I would if this was a right triangle. I don't think this is a right angle, especially now that we've marked it. So what I can do is find either the side length or the angle using the established relationship of c. Why don't I use the law of sines to find side length side length A, and comparing it with side of C, or the side of C. So let's do the sine of C divided by lowercase c. This will be equal to the sine of angle A divided by side A. Alright, now, two things that I see that might be a problem here. I don't have either of these informations. And the second thing is, I'm using C. What if my answer to C were wrong? Wouldn't that also make this mistake? Wouldn't that also make the values of A incorrect also? So I think the safer approach might be to do what? I still want to find the values of A, angle A, and side length A. But because angle B is already given and side length B is already given, what I want to do is I want to use a sure thing. I want to use this information because I know that information was given to us. The other thing is, in a triangle, all 3 angles have to add up to be 180 degrees. So I feel like we are able to subtract 107 and 25 from 180, and that will give us the value of the angle for angle A. So I think I get 48 when I do that. So I get like 132 and 48 degrees. Okay, so I actually do know this because I know 2 out of the 3 angles. So we'll put 48 here. Now, which 2 will I multiply? I'll multiply this and that because these have the numbers and divide it by the third. Take out the calculator. 15 sine 48, close the parenthesis, divided by sine of 25. Hit enter. We're going to approximate this. This is also a side length because it's a lowercase a. So lowercase a is approximately 26.376 units. This triangle is solved. I know all 3 side lengths and I know all 3 angles. So this is one instance of when you can use the law of sines. Always, always, always use the law of sines when you have a side length across from an angle. Number 2 does not contain any picture. We'll do the best that we can to figure this out. I will always draw some sort of picture. It does not need to be super detailed. A and B and C. Let's see, it says angle A is 51 degrees. Angle B is 44 degrees. And lowercase c or side c is 11. Because I know 2 of the angles inside the triangle, I'll do my math. I'll do 180 minus 51 minus 44. This gives me 85. So again, this is not a right triangle, but the law of sines can be used as long as you have a side length across from an angle. Right now, we only had two angles and a side length without the opposite angle. But knowing two of your angles really indicates that your third angle is available for you to find. This is our known relationship, C to C, so sine of C divided by C. I'm going to solve for A next. What's the sine of 51 divided by? Divided by lowercase a. Multiply these two and divide by that. 11 sine 51 degrees divided by sine 85 degrees. This is side length little a. I'm just going to write it next to it. A is approximately 8.581 units of length. And side length B. Now I don't want to use side length A because if this answer were wrong, then using it to find side length B would not be wise. I'm going to go back to sine of C, the given information, and set this up. Sine angle B divided by side B. Multiply these and divide by that. This is going to take us to the end of our first video. And we're going to approximate it. Let's see, did I do something? Something was wrong because I noticed that this answer was the same. My mistake was I took angle A a second time. I really needed to take angle B to find side length B. What I'll do is I'll second and enter. I'm going to scroll backwards and type over the incorrect angle and place the correct angle there. Now I know the answer. B is approximately 7.670. You do want that 0 there. You do want the 0 at the end. It indicates that it was rounded because that 4 wasn't enough to round it up. So this concludes our first video. Please move on to video number 2.